Marc, you are a geologist. You are a member of the Association for the Study of Peak Oil. And more importantly, I think you have a career about 45 years for big oil companies in doing exploration and scouring the world to identify oil reserve and oil fields. And we thought that was really interesting because usually in the field of ecology, we don't talk to big oil much, but I think that's really interesting to see that you have worked in oil industry and you have a lot of expertise in this. And this is what led you today to talk about the transition away from oil and toward other type of energies. And we talk a lot about in the Erasmus program about mobility and about avoiding planes,
Yes.
avoiding cars, going to train, going sometimes to electricity. But we'll talk with you about how electricity hides very different realities. And so we thought it was really interesting to go back to the purpose of the transition and why is it actually important to go away from coal and oil and toward other type of energies. Um, and again, if you have any questions for all our guests, I invite you to write them in the chat or if you just wait for the end of the meeting, then we'll have
Yeah.
the short Q&A.
A Q&A session at the end.
Exactly. All right.
Okay.
And I'll let you get started.
Okay. Thank you so much. So thank you for the invitation today. As you may see on the screen, we'll discuss about fossil fuels, uh, how these fossil fuels are as a grip on the global economy. That will be the main part of the talk, because I think it's quite good to have conscientious of that. And we will also look at how we can get rid of it, or what we call the energy transition. So let's start with the table of content. We will pass through the introduction, a certain length of introduction in order to cope with what is the energy system today, globally speaking, and what has been the evolution since the end of the 21st century. Then we'll go to the stranglehold of fossil fuels on global economy, and I will pass through three main type of fossil fuels, coal, oil, and gas. And then, as a conclusion, we will see how we can replace these fossil fuels, why, what are the reasons, how, technically, and through which a new fuel we can do it. Alors, just as an introduction, a few words to sum up energy. Energy is just radioactivity. All forms of energies are directly or indirectly deriving from nuclear energy. Solar first, clearly evident, obvious, as a nuclear origin, because this light we receive from our star, the sun, is directly linked to the fusion of molecules of hydrogen at a quite high temperature, as you can see here. And this fusion energy, this radioactivity, is emitting photons and light and heat on the planet, on the Earth. After that, thanks to this solar energy, all the rest, or practically all the rest of the energies are coming. Solar energy, of course, but also hydroelectricities, because the water cycle is directly linked to the solar activity, mainly rain or snow. The aeolian, the wind energy, wind is also created by difference in temperature at the surface of the planet, and, which is maybe less known, biomass is also, thanks to photosynthesis, a direct creation of the solar energy. Accordingly, fossil fuels, which are only fossilized animals or vegetal biomass, is also a nuclear energy, an old nuclear energy. And we will come back on this when speaking about fossil fuels. Geothermal energy is also a form of radioactivity, but from our planet, from the core of our planet directly, by the radioactivity of a certain number of radioactive minerals like uranium or potassium, which give the temperature at the Earth. And then atomic energy, which is man-made, this one, is not a natural one, is also linked to radioactivity because we just fission these radioactive elements. So have that in mind, all forms of energies are coming from radioactivity, whatever the Earth or the Sun. What has been the evolution and what is the today status of energy at the global level for the whole countries of this planet? So the uh, consumption today is around 625 exajoule. Exajoule is a measure of energy. The joule is a measure of energy, but the joule is so small that we are obliged to use exajoule, which is, as indicated on this slide, 278 terawatt-hour of energy, so something considerable, or 15 gigaton of oil equivalent consumed every year on this planet. There are clearly three main energies leading the race: oil, coal, and gas. And probably not known from a lot of people, coal is actually the winner of this race because coal, as you can see on the curve, has been increasing a lot during the last 20 years. So it was the third energy at the beginning of the century. It is now at the top. 200 exajoule of coal used in 2022, and it is more in 2025. We will see it later on. So the coal has been the winner of the race, but still oil and gas are also leading the race, being second and third. As you can see, renewable are still very low in terms of energy production. It has increased a lot during this century, but not at the level of the others. It's only 15 exajoule more than at the beginning of the century, when the coal, as it is highlighted here in red, has increased by 90 exajoule in only 20 years. Total of the energy consumed by the humans in all the countries have increased a lot during this last century. It's more than 200 exajoule added to the figures at the beginning of the century, the 21st century. So a lot of increase linked clearly to demography, to population, and within these energies, coal is the winner. But why? Why the winner is this king coal, as said in the US? Why? Because the coal is very easy to use. It's very simple to heat water, to get water vapor and do electricity, or to use the coal directly for heating. It's quite well distributed. The reserves are generally well known. It's controllable, which is very important in terms of energy, 24 hours, 7 days and 7 days. And it is also essential for the renewable energies because you need coal to produce, to yield the steel for wind turbines, for example, or to do and to generate silicones for photovoltaic cells. It's a record of production, as I was saying, last year. 9 gigatons of coals, more than half being consumed in China. So since the Paris Agreement, and we have a 10th anniversary last year, we have had 6,500 coal power plants. It's considerable. It is clearly unpredictable 20 years ago. Everybody was thinking coal will decrease. That has not been the case. All the forecasts are wrong, whatever they are, from oil companies or for international companies, institutions, or NGOs. And there is still coal-powered plants in construction, mainly in Asia, China or India. And that allow us to see what are the qualities and the constraints for each kind of energies. All the energy source should be, I think, reliable. You can have access and easy access to them. Affordable, low price, cheap energy. Otherwise, the people doesn't use. And by the way, coal is clearly the energy of the poor. But should be also sustainable, meaning in terms of climate, no affecting the climate, clearly not the case of coal, not affecting the health, never it is, and no surface footprints or the less surface footprints we can, and a low water requirements. So we can try to describe all the energies with these three qualities. Coal and oil, affordable, very affordable for coal. It's very cheap, very reliable, easy to transport. This is solid for coal, liquid for oil, it's easy. Abundance is questionable. For oil, there is a question. For coal, we have still a lot of reserves. Gas, more or less affordable. It is clearly much high price now in Europe, for example, after the crisis with Ukraine. It's more or less reliable. Look at the Russian pipelines with gas inside. They are now cut. Quite abundant, a lot of reserves, but very difficult to transport. It is a gas, it's not a solid or a liquid. And we need to have liquefaction for transporting it all along the planet. Not very sustainable because still a lot of gas emission. Renewable wind or solar, affordable because the price is decreasing a lot. You can put them practically everywhere. But generally in the price, we didn't integrate backups. What do we do when there is no wind or no sun or no sun? And connections. We need a lot of connection for all these energy plants. Low reliability because intermittency or needing a lot of batteries if you want to avoid the intermittency. It's transportable as electricity. Abundance, and more abundant. Sustainable, yes, but required a lot of land, so the surface footprint is important, and need metals. Renewable energy, very affordable, fairly reliable, because with the change in climate, we could have problem of low water levels in the future. Transportable. It's a long-term abundance, I wonder, because of this climatic change. Geothermal energy, affordable, but not very easy to transport, because we transport hot water and we cannot do that on a long length of kilometers. Renewable, certainly. Nuclear fission, affordable, low price, reliable, transportable, but question about sustainability, long life waste, and necessity of lot of water requirements for cooling. So I will come to coal. What is coal? Coal is a fossil rock which is modified, transformed from organic matter, organic plant, trees, leaves. We know it as peat at the beginning, and progressively, with a burial, with increasing pressure and temperature within the earth, they gradually transform these plants, this organic matter, in coal, losing all of the atoms like oxygen, sulfur, phosphate, just keeping coal and the carbon content inside. Some of these coal, like lignite or subbituminous coal, are mainly used for power generation, for electricity, wherever anthracite or bituminous more for cement or steel production. So as I was saying, production has been at the top last year, 9 gigaton. Coal reserves are quite abundant. We say 100 years of current consumption reserves, and dominates by 5 countries, USA, Russia, China, Australia, and India. But a lot of other countries, you have it here in gray or pink, have also smaller reserves, but have coal reserves. So it's fairly well-balanced distribution, and that was of the reason, clearly, of this increase in coal consumption. As you can see it on the diagram on your left, production has been always increasing, and is now increasing mainly in Asia and in Australia. What are the main use of coal last year? The main usage is electricity. 2/3 of the coal production is used in electricities. And coal is always the first medium for yielding electricity today. 25% of the coal is used for steel industry, and the rest for cement plant or chemicals. Steel and cement are sectors of activities of industry where it's very complicated to replace coal, because you need to reach temperature more than 1000 degrees Celsius. So not so many alternatives. Clearly, the electricity sector could be replaced, and I hope will be replaced, by renewable energy or nuclear power. But as you can see, it's not the case today. As we were saying in
Marc,
introduction,
juste une petite
yes,
seconde. Est-ce que tu pourrais cliquer sur paramètres d'affichage, là, sur le
oui,
PowerPoint?
oui.
et basculer entre le mode présentateur et diaporama. Comme ça, les diapos seront un peu plus grandes pour le public.
Is it good?
Perfect. Better.
Okay, thank you. Uh, yeah, I was saying, what is behind electricity? When you take your car or when you take a train, even more complicated, which kind of electricity there is behind? Is it renewable or is it coal, like it is in this sketch? Because if it's coal, you can have a nice electricity car. There is absolutely no difference in terms of emissions. That's the same thing. It's just you don't know. So going to oil now, I would like to first tell you there is different kind of oil. It's not the same thing everywhere. We have a classification by density and viscosities. You can see it on this picture here, on this photo. Light oil on your left and very heavy, extra heavy oil, as we say, on your right. You can see it's not at all the same thing. When we speak about Venezuelan oil, for example, it is clearly on the right of the picture, extra heavy oil. You have here the gravity and viscosity. I will not enter in this detail. Let's say that water gravity is 1 and viscosity is 1. And you can, like that, compare. So you have generally the oils less dense than water and more viscous. But this kind of oil are very different and have not the same use. Main use today of oil, clearly it is road transport, cars, lorries. It's slightly 50% of the present production. Present production, which was also in 2025 a record, world record last year, 106 million barrels of oil each day, which means 1,000 barrels a second. It's just huge. Very, it's an industry which is a giant. So a lot of this industry is for road transportation. Then the rest, petrochemicals for plastics. Practically all the plastic are made of oil. Some of them coal, but few. Aviation, marine transportation, and few of the oil for heating. It's not used practically now for that. So you see, oil is linked to transport. May I remember when 3 years ago, and probably a bit higher now, on this earth, there were 1 billion cars for 8 billion inhabitants, 400 million commercial vehicles, trucks and lorries, a global road fuel consumption of 6 billion liters a day. Small country like France, for example, is 46 billion liters a year. And a small calculation, you can see that, for example, in France, if you want to replace all the vehicles, thermal vehicles we have today by electric vehicles, we will need 30% of the electricity consumption, the French electricity consumption, which is quite a lot. Alors, the main question today for oil is finally, we have found a lot. but we are not finding anymore a lot of oil. Exploration is clearly decreasing. You have the history of the oil discoveries starting, let's say, 1 century ago, uh, mainly in the US, Azerbaijan, Romania, and with big discoveries in the Middle East, like Burgan in Kuwait or Ghawar in Saudi Arabia. But you see that since 40, 50 years, the discovery are decreasing. That's the histogram you have in gray here, onshore or offshore. And above all, the production, which is the blue line, is fairly above now the discovery rate. We are discovering around 10% of what we are of the consumption. So at midterm, the reserves will be exhausted, and we will see when. It's quite a difficult task to extract oil. It's a long chain of exploration and production, starting with exploration, and then in case of discoveries, and it is rare, uh, more or less the probability of success is around 20%, meaning you have 2 wells positive on top of 10. And then you have to assess the discovery, to develop the discovery. And when it is offshore, as it in this picture, you can see when you need a lot of time to do that, 3 to 10 years. And then production during 10 to 50 years for the biggest field. And then you abandon it. So it's a long story, 60, 70 years for exploration production of oil. And when we say oil, we say also water. Because when you are producing oil, all the wells, all the oil wells, you are rapidly producing water. And this water, which is in the ground, it's very hot and very salty. So water you cannot use, you have to re-inject, generally in the same field. But in this case, clearly the oil production is decreasing, as you can see it, following the green curve here, whatever you are. And that is quite a problem. It could be also a solution because this water is hot and could be a good geothermal field also at the end of the oil production. And some of these fields, oil fields, are already now transformed into geothermal fields. What is the production of oil today? More than 100 million barrels a day. We have reached, it's the red arrow here on the slide, the conventional peak in 2008, 2009. We thought that the peak could have been reached in 2019, but as I told you a few minutes ago, actually 2025 has been has seen a production more important than 2009. So the peak has not been reached. It's mainly linked to what we call non-conventional oil or shale oil, which has been developed in the US since a bit more than 10 years now, and which has permitted this increase in new hydrocarbon oil production. So what is the future for this oil production and oil extraction? One of the key questions is the near term is becoming problematic because we need to spend a lot of energy to produce this energy. Or that is what we call the ROI indicator, which is the energy return on the energy invest. So at the beginning, 50, 60 years ago, uh, when you extract 1 barrel of oil, you needed, I don't know, 10% of energy to extract the oil. But now it's growing. You need 1 barrel of energy invest in order to return 3 barrels, more or less. And the end will not be able to produce anymore when the energy you need to invest to extract the oil will be equivalent to the return. Conventional oil, which is a good quality of reservoir, good quality of oil, will have no problem, but this one, as I show you, is decreasing. We have not so much. Unconventional oil, we have a lot, whatever it is, extra heavy oil or shale oil, which they have, both of them, they have problems with one of them, the reservoir, and the other one, the fluid. And I don't speak about synthetic oil, which is clearly out of the scope. Uh, what are the reserves today? That's an important question, but we need to have some definition first. We have adopted the following rule. We call proved reserve the reserve which can be produced at the economic condition and technical condition of today. I have always taken the analogy of the fishing. Proven reserve, the fish is caught and already in your basket. Theoretically, you could have a good dinner. Probable reserve, you have only 50 chance to produce these reserves with the current technical and economical. So short term is not easy. Maybe at medium term, if, for example, the price of oil is increasing, you will be reasonably certain to produce. To continue with the analogy of fishing, fish is caught, but it's still at the end of your road in the river. So maybe it will not come on the river bank. Possible reserve, it's the reserve which you have only 10% chance of production. You need really to see the economical or technical condition to increase. So it's far from having the fish in your basket. The fish is still jumping in the river, and even you don't have a road. You don't have a line to catch it. And then we have what we call the resources. That is the exploration. You have not proved any reserve. So it's not yet discovered. It's estimated, but you don't know. So analogy, you have a river, but you don't know if there is a fish in. So you have a lot of work to do. And we have a problem today with this reserve because the estimates done by different association, organization are very different. When you look at what is saying, for example, the International Energy Agency, IEA, they said you have 1,800 gigabarrel of oil. It's always increasing, which is clearly physically not possible. When you look at other associations, and for example, in the ASPO, the one I have working with, we derive to 800 gigabarrel of oil. So the gap is considerable, more than the double. I still think the green curve is the one we have in mind, we should consider, because the red line is more political reserves. Everybody wants to have reserves in order to produce more today. And that's the problem of OPEC, and IEA. A few words about gas now. The use of gas, uh, the, to sum up the natural gas, it's CH4. Electricity generation, it's more and more the case because a lot of countries, the US as first, are replacing coal by gas. But it's also industry, more and more fertilizer, steel, cement, petrochemicals, quite a bit of heating, 20% for residential houses, small other things like hydrogen production, transportation, or losses, because it's a gas, and there is quite a lot of loss. Again, have in mind, 2025 world record production for gas. 4,200 gigacubic meter of gas. So both coal, oil, and gas, 2025 was the year of world record production.
Okay,
Alors,
just briefly, we're
yeah,
getting close to
natural
the end
gas,
of the
what
webinar.
next?
Yeah,
We
so
think
if
we
we
have
can.
gas still for one century, let's say. Uh, but I think the curve is interesting also. We will reach the peak in a few years, in a few decades. Alors, conclusion. Why we need to get rid of these fossil fuels? First of all, because the greenhouse gas emissions are clearly directly linked to fossil fuels. It's an extraordinary correlation. No doubt about that. But the difficulty is also that oil correlation, let's say fossil fuels correlation, and wealth per capita is also an extraordinary correlation. A fuel finally this fuel permit the human development and has permitted the human development since years, since decades. How could we go in a world without any fossil fuels? There is some remedies, mitigation first. We could try to use carbon or to capture it, so to avoid these greenhouse gas emissions. You could substitute in changing the usage or without changing the usage, as I indicate here on the slide. The main thing being going from thermal vehicles to electricity vehicles, but with an electricity decarbonized. And then we could also try sobriety, which is difficult to propose to the poorest countries in the world, in the south, or to the most addicted countries like ours in Europe. And we have some challenge because fossil fuels, for example, they are needed in the four most basic products the human economy need today: cement, steel, plastic, and fertilizers. And that coal or methane or natural gas is practically compulsory. But the world at the end will be without fuels. We have seen that the reserves are not for eternity. let's look at that. Fossil fuel production from cradle to grave, actually. Cradle to 2 centuries ago, there was no fossil production. And by 1 century, or let's say 2 centuries, we'll have no more fossil fuels. So that will end anyway. And to finish, the transition is a bit like the Tower of Babel. You have it here on this frame by Peter Bruegel. The transition will be difficult, will be expensive, will be never-ending, heterogeneous, but I think inspiring for new practices and compulsory. And that will be the end of the talk. Thanks a lot for listening.